Welcome, everyone. My name is Carm Taglienti. I'm the Chief Data Officer and Distinguished Engineer at Insight, and I'd like to talk to you today about not letting the lack of power and cooling stall your AI implementation. And specifically, we'll be talking about AI solutions with Schneider Electric as well as Insight. So let's get into the opportunity. So if we just talk a little bit about the market, what's happening with AI, as we're all really aware, there's about 300 billion over the next 3 years that'll be spent in this area, on-prem and in the cloud. This is according to Gartner. And so when we think about some of the challenges that are facing us, there's going to be a lot as it relates to thinking about things like privacy and security, the cost to run and scale the AI workloads, which we'll be talking a lot about today, especially as it relates to sustainability, industry regulations that we might have to worry about, as well as real-time processing and low latency requirements, which require us to be able to collect data at speed and to be able to process it. So we'll be going into some of these things today. So ultimately, the solution has to do with making sure that we can create and build an AI infrastructure that can support our AI workload. And we do this in tiers. And so we think about the AI infrastructure as sort of being the central part of our infrastructure or our solution domain. Then we'll look at the platform related to AI and then the application. So if we think about the way AI is thought about in today's world, we really think about the business use case first. We don't always just start with infrastructure or say, hey, I just need to buy a whole bunch of GPUs in order to be able to support my environment. We really do want to look at what problem are you trying to solve? And then we think about what is the best way to support implementation within that environment. And an on-prem solution is a good way to do it, but we would need to know what are the expectations of how much compute do I need, CPU or GPU, and then also how am I going to rack it, stack it, cool it, support it, access it, etc. So these are the things that are really important. So what I'm showing you now is this AI-enabled stack concept. And so what this really is about is it talks about all the layers of an AI solution. And if we think about the focus of today's conversation, we'll be talking about the infrastructure stack primarily, which has to do with being able to run on premise in our data center. And then we'll talk about what are some of the components that we want to put in place in order to be able to support that infrastructure in a sustainable way. But just so that we're all aware, the general solution framework looks like adding an AI platform, understanding how we are going to operate within this environment, and then, of course, addressing the needs of the business, which is really the important part. So one thing in addition to the GPU that NVIDIA provides is the software. And if you talk to the NVIDIA teams today, or even Jensen for that matter, he will tell you that NVIDIA is becoming a software company. So this is what we talk about when we think about the software stack. So NVIDIA produces a software stack component called AI Enterprise or NVAIE, and that allows us to be able to create solutions on top of the infrastructure that is supported by the GPU. And so we will get into the topic of discussing how do you create that infrastructure and support it by using some of the products that are provided by Schneider Electric. And so we'll get into that in a minute. But as I talked about, the core of the solution is the infrastructure. If we're going to run on premises, then we have to think about the AI infrastructure. We add on top of that the AI platform, and then, of course, the solution. So this is really just sort of a slightly different depiction of what I was just describing earlier as it relates to creating the AI infrastructure components and then allowing us to be able to focus on that, to be able to build out the rest of our application infrastructure stack. Here's a little bit more detail as it relates to that, but what we really mean by the AI infrastructure is this is taking a very prescriptive approach that allows us to be able to manage our AI infrastructure. It needs to be repeatable, and we have to understand exactly what the outcomes that are expected from it. And by using this kind of disciplined approach, it allows us to be able to understand what are our regulatory compliance standards, what are the power consumption metrics that we want to be able to hit, how do we manage sustainability within our environment. And that's really what we're driving toward as we think about this. Okay, so as everybody is aware, the demand for AI is skyrocketing. So with the use of models and applications, we are processing vast amounts of data. We need more compute and storage and networking and memory to be able to support all of this. Okay, and this is from a white paper that was published by Schneider Electric, which talks a little bit about how this operates and how this works. Before I was talking about Gartner, and you can look across the market and you'll see similar kinds of statistics. The models themselves are rapidly growing and becoming more complex. And then it requires, of course, more consumption and power for us to be able to support it, or computational power in this particular case. But we will be, for example, creating inference engines that allow us to be able to serve up the models from a computational perspective, or in cases where we want to fine tune or train models, we'll need the GPUs in order to allow us to be able to train those models specifically. So that, of course, requires a lot of power and cooling as we think about this kind of an environment. Which brings us to power and cooling. So this is the backbone of our AI. So it's essential for AI performance because efficient power and cooling will be crucial to maintain a stable and uninterrupted AI operation. So if I'm training a model or building a model, I certainly can't stop in the middle of my training run in order to be able to, say, deal with an overheat or some kind of capacity exceeded workload that I need to address. So I need to ensure that I have consistent energy and temperature management in order to be able to function at peak capacity. And we'll get into this too in a little bit more detail. So not only do I identify this as a potential area of concern, but we also need to understand how to measure and monitor in order to allow us to be able to understand when we might be getting into a situation that we have to address, and then what to do about it, which we'll also talk about. We also want to protect our investment. So if you have made the purchase and the capital investment in terms of buying equipment in order to be able to support your AI needs, which includes your infrastructure environment for things like inference or for training and fine tuning your environment. And this also applies not just to generative AI, but also to classical AI. You can do both, but you want to ensure that you're protecting your investment. So because of the high value of AI hardware, we want to ensure that we can reduce downtime, take advantage of the equipment that we've purchased, and we certainly want to avoid repair costs. So overheating of equipment can cause damage. We definitely don't want that to happen. So we want to ensure that we're able to keep our systems up and running to peak efficiency, and that allows us to be able to then maximize our investment. We also can address high density needs. So a high performance AI setups will generate significant heat. So we need to ensure that we have specialized cooling systems in place so that we can handle the density and prevent any performance dips that might be associated with the scaling down of the processor in order to be able to accommodate an excess of heat, for example. So there's a couple concepts here that we'll talk about. Rack density is one, so fitting more gear into each rack, which is important for us to make sure that we can keep the latency low and efficiency high. So basically the proximity of the gear allows us to be able to transfer data and information and compute within the context of the rack. That allows us to be able to run faster and with higher efficiency. More power into smaller places. So this is a challenge to get enough power and backup power into each rack so that we can support the additional consumption that we'll be supporting with higher rack density. And of course, cooling, making sure that we can ensure that the clusters that require advanced cooling techniques are able to stay cool. And we may need to think about things like liquid cooling, for example, especially as we start thinking about next generation processing power, like Blackwell, for example, which will be predominantly liquid cooled. So the big picture is we have to have some ability to be able to monitor this in order to understand how our systems are performing, and then when we need to take action based off of that. So Schneider Electric supports NVIDIA AI solutions, making sure that they can provide the infrastructure that you need. So we talked about these components already, but what we can take advantage of with Schneider is the racks, so we can provide best-in-class racks and enclosures to enable high-density computing, as I described earlier. The power is reliable, and it provides us with uninterrupted AI operations with consistent power. And then cooling, of course, advanced cooling solutions, which would ensure optimal performance of NVIDIA AI technologies. So again, making sure that things like training runs that we might be running for maybe days at a time, or even inference, which is, we may have high capacity inference or connectivity to allow multiple users in a multi-tenant environment access within this environment. So we want to ensure that there is no interruption in terms of the operation of the system. And then software and control, of course, to be able to smartly manage a seamless integration and efficiency within our environment. So first, power management essentials. So here, when we talk about reliable power systems, we're talking about uninterruptible supply systems that ensure continuous power, preventing any data loss or hardware damage. So this, along with sustainability requirements, allows us to scale to 100 kilowatts, and it supports expanding AI infrastructure. So as we add more capacity and increase the density, the power systems will allow us to be able to support that. It also will do things like high voltage distribution. And so the AI clusters will demand substantial energy, and high voltage distribution will maximize our efficiency, which will reduce any power loss across the equipment. So we talked a bit before about rack density, but we'll also want to ensure that we can maintain performance consistency across this environment, and power is one way to do that effectively. Advanced cooling, another key area. So here, focusing on liquid cooling for dense environments. So liquid cooling would provide targeted temperature control, especially in these high density setups where we're putting a lot of compute into each one of the racks. So this would allow us to be able to control that temperature effectively. And we want to manage heat, of course, that was generated by these powerful AI clusters and processors that do that. And then also, this would allow us to be able to achieve system reliability. Another component of this is close coupled and aisle containment. So in this particular case, if you are looking at the organization of the data center, you want to ensure that we use close coupled and aisle management in order to be able to provide a focus on specific hot and cold zones, and then optimize energy use and ensure high efficiency cooling exactly where it might be needed. So we can help to lower the overall operational costs. So these will be pretty big components as we think about this. And of course, Snyder will provide the components that allow us to be able to support the advanced cooling solutions for the AI workloads that we've been describing. And I talked earlier about monitoring. So this is another important characteristic. So within the context of monitoring and control, we have EcoStruxure that allows us to be able to perform real-time monitoring. We can perform things like continuous oversight of power and cooling systems. We can enable immediate response, as I said before. So if something gets out of our thresholds or out of our control limits, then we want to be able to understand when that occurs so we can take action, we can reduce downtime, and then keep the operation smooth. We can also do things like digital twinning and DCIM, or data center infrastructure management, which allows us to simulate and predict what our maintenance needs might be. So if we're collecting information, we can actually use that information to be able to do things like predictive analysis of the existing environment, and then be able to hopefully identify when challenges might occur. But digital twinning can also allow us to be able to do things like simulation. So we can actually do proactive problem solving and resource optimization. So the software and data collection component of this is critical to ensure the software operation and the hardware management and maintenance continues in order to be able to support the AI workload that we're putting within our infrastructure. So how do we achieve sustainability goals? So AI-driven energy efficiency, we can use techniques that allow us to be able to control precisely and adjust energy usage to reduce any waste that might be occurring. We can lower our carbon footprint within the data center and support company-wide sustainability targets. Okay, so a lot of this comes as the result of not just efficiency in terms of the organization of the infrastructure itself, but also understanding how to monitor and then take action as it relates to being able to reduce our carbon footprint, but also to prevent things like downtime or specific types of conditions that might impact our ability to support our AI workloads. The next one is automation for optimization. So here we talk about automating monitoring systems, which would identify inefficiencies in real time and then offer actionable insights in order to optimize energy use and further reduce the environmental impact. So here in this particular case, we can use automation that allows us to be able to respond to alerts automatically, or even things like autonomous computing that allows us to be able to then take predictive action as it relates to maybe things that look like they might fail. Maybe we're approaching a particular heat threshold, for example, within a particular rack, which might shut down a server within our rack. We want to ensure that we can identify that early and then recognize which actions we might take. Maybe we do workload distribution, for example, to be able to move it to another part of the infrastructure in order to be able to support our continued workload. So we certainly don't want things to shut down. We want to be fault tolerant and resilient within this environment, and automation can help us to do that. So we'll talk just quickly about a use case here. So here we are working with we're driving energy resource efficiency and savings with actionable data. So again, as much as I talk about monitoring and all of the interesting parts of the infrastructure that we're supporting and building, the monitoring, the data collection is going to be the most important part because that's where our intelligence is at the end of the day. So here the customer challenge was to efficiently manage its resources and stay ahead in a competitive market. So Blackstone required actionable energy and sustainability across all of their operations. So here the solution was to leverage a Schneider Electric infrastructure in order to be able to support aggressive energy management and sustainable energy. So they were powered by NVIDIA's HGX 100s, which are 3 times faster. So again, a lot of computing infrastructure in order to be able to ensure that they can accommodate all of the financial metrics and calculations and models that they wanted to be able to support. So which required a lot of power and required a lot of equipment in order to be able to do that. So here in this particular case, we use things like high voltage power distribution systems or PDUs and EcoStruxure Resource Advisor to capture and normalize energy and utility data in order to do things like I was talking about before, manage energy propagation, sustainability, and to ensure when we could either pinpoint opportunities for efficiency improvements or to identify when we might have potential issues that would have to be dealt with in order to maintain a degree of resiliency. So the results was basically active energy management programs are now in place across 20 plus portfolio companies. So basically the first use case allowed us to be able to propagate this into many more of the organizational components of the company across multiple portfolios. And here, this is really important. So advanced computing tasks that demanded tightly linked GPU clusters with optimized software support. It provided us 30x in terms of speed, as well as 3x more energy efficiency at the large language model inference than its predecessor. So again, efficiencies around things like inferencing, here in this case, generative AI solutions, 3x lower TCO as it relates to total cost of ownership, of course, and then requires 5x fewer server nodes. So here it just became much more cost efficient and using less capacity in order to be able to support our use cases. And then 20x more efficiency, energy efficiency than CPU for higher APC and AI workloads. So this also has to do with making sure that we identify how to take advantage of the GPUs, and we can then create efficiencies which would allow us to be able to ensure that the NVIDIA GPUs will perform much better in the high performance computing arena, which is what they're geared toward, as opposed to CPUs, which are more for standard style processing. So ensuring that we create the right type of architecture and then create not just better performance, but also better energy efficiency. So these are really important considerations. So how do we maximize the capital investments? So HGX 100 for high efficiency is the powerful processing capability, which decreases the need for multiple server units. So this will enable more efficiency and cost-effective infrastructure. We can also lower TCO with fewer nodes. I already talked about this in the example, but basically a reduced server footprint means less physical space and energy consumption, less to cool as well, less power to consume, and this will result in a lower total cost of ownership and higher return on infrastructure investments. So it's not just a matter of density, it's also a matter of ensuring that we select the right GPU for the job in order to be able to perform the right type of compute, whether it's inference kinds of computes in the case of a large language model, or it's training and testing of a particular model that we might create even in a classical AI sense. So high performance computing environments typically are geared toward these kinds of workloads. And so we want to make sure that we're using the right kind of infrastructure to be able to support it. And then of course, ensuring that we can bring an uninterrupted set of power to that particular infrastructure and then be able to monitor it and ensure that we can cool it effectively and then manage it efficiently, even as it relates to things like communication between the processors, especially in distributed high performance computing environments. Another area to think about is responsible AI and data regulations. And so software and control, which is supported through the monitoring and management infrastructure within the environment, will allow for secure operations. So here, reliable power and cooling systems will support data protection and compliance by keeping the infrastructure stable and then preventing any data loss. So another critical component of this. So you would think that what is the impact as it relates to the kinds of things we've been talking about on the infrastructure? Well, of course, protecting your data is going to be an important part of it. So we have to meet strict regulatory standards, ensuring that we don't have things like downtime or any ability for the environment to be in an unstable state. So we have to be able to make sure that we can secure and protect our environment, ensuring that we have uninterruptible power and also the operations of the systems are kept in a resilient and fault-tolerant state. Also, transparency for responsible AI. So real-time data and monitoring provide transparency into AI operations, which supports responsible AI by using and enabling accountable and traceable data handling. So basically, this has to do with the fact that we need to have transparency into access and as well as what constraints are being put in place in order to be able to support responsible AI and software and control within the component systems as part of the Schneider Electric solution allows us to be able to do that effectively. Okay, so let's wrap this up. And what's our call to action? So we want to focus on optimization of AI with power and cooling, and it really talks about effective power and cooling management are key to maximizing performance, as I described. So there are many considerations for not only efficiency, but also ensuring availability, resiliency, and as well as in cost efficiency. And so we want to make sure that we focus on all these as part of it. Some of it is going to be related to the technology and infrastructure components that are made available by NVIDIA as well as Schneider, but also it has to do with being able to monitor how those components actually work together, and then to be able to take advantage of the fact that we can control whether or not we are exceeding, for example, high temperature thresholds, and then how to take action as it relates to that. And then we can also drive sustainability with AI management. So AI-driven energy controls reduce the environmental impact. So again, making sure that we only use the power that we need to for certain workloads that we're supporting. We also can take advantage of the fact of things like high density, better cooling, which will allow us to be able to meet sustainability goals while we can enhance our operational efficiency. We want to make sure that we handle the workloads, of course, because that is where our demand is. We want to do it in a sustainable and efficient way. And then the important part here is to invest in scalable infrastructure. So future-ready infrastructure, which would support your growth needs, is really going to be important as part of this. This will provide you with competitive advantage. It'll support your AI and technology advances without frequent overhauls. So one of the worst things that you can expect to do is that, if you have over capacity, that's a problem. So you're paying for things that you don't necessarily use, or under capacity is you may end up getting into a situation where you might be, if you're under capacity, you might end up creating overuse of your systems. They might induce things like increased temperature and power, and it could also result in loss of access to that equipment or reduction in availability. So it's really important to understand what your environment looks like, what your workload expectations are, and then how you're going to create the infrastructure that can support it. So making sure that it's scalable, you can monitor it, and understanding what actions you can use in order to be able to address it are really an important part of how to do this. So with that, I will leave it up to you to look into this and take your next step. And if you have questions, I'm certainly happy to answer them. Make sure you reach out to us. We'd love to work with you to help you to solve your particular power and cooling problems as it relates to your AI infrastructure, or even create your AI infrastructure for the future.